Okay, green to one and all. Give me a confirmation if you guys can hear me. Good evening to one and all. Give me a confirmation if you guys can hear me. Yes or no? Can you guys hear me? Give me a confirmation. Perfect. Okay. So welcome to day 6 for this bootcamp. Today we're going to start with pandas and we're going to start with machine learning. Okay. Now we are going to see why we have to use machine learning and how we can easily process our machine learning model. Okay. So before going on to that, we're going to start with pandas today. Okay. Why we have to use pandas and what are the need of pandas, right? We're going to discuss that today itself. So let's start this. So today we are going to talk about pandas. First of all, pandas is also a library of Python. Okay, pandas is a library of Python, and the use of this pandas library is that is used for data manipulation, data cleaning. Let's do this. Data exploration, and at some extent data visualization as well. Okay. Now, always remember one thing when we talk about data analysis. Okay, in the data analysis, we have these four structure. We have to perform data manipulation, we have to perform data cleaning, we have to perform data exploration, and we have to perform data visualization. That summarizes to data analysis. Okay, so if you're looking forward to go into the field of data analyst, okay, if you want to go on to find out some insight from a data, then you should know about data manipulation, data cleaning, data exploration, data visualization, among which this data cleaning is very important, among which this data cleaning is very important. Okay, if you don't know exploration, perfectly fine. If you don't know about manipulation, perfectly fine. If you don't know about exploration, that's good. If you don't know about visualization as well, okay, that at that extent it is all good. But if you don't know about data cleaning, then definitely it will be very difficult for you to go and make impact in this data analysis field. The reason being is that approximate 70% of the time approximate 70% of the time a data analyst consume in data cleaning. About 70% of the time a data analyst consumes for the process of data cleaning. So over here manipulation is easy, exploration is easy, visualization is easy, but data cleaning is very difficult. It is lot trickier. Okay, so it has been requested, so kindly focus on this data cleaning part. Kindly focus on this data cleaning part. There are several modules and libraries that can help you out. One module that I can mention over here is the RE module that comes handy with Python. That will going to help you out in the data cleaning process. Okay. Now let's come back to the topic of pandas. What exactly is a pandas? This panda is a Python library. Or you can say it's a data manipulation tool. With the help of pandas, you can perform the data manipulation, you can explore the data set, and at some extent you can perform some cleaning and visualization as well. Is this clear? Is this clear? Till here it's clear? Yes or no? Till here it's clear? Perfect. Okay. Now, pandas is specifically being designed to work with the data frame. Pandas is been specifically designed to work with a data frame. What is a data frame? Now, first we have to understand, when we do some analysis, when we try to form some models from machine learning, most of the time we use a two-dimensional data set. Most of the time we use two-dimensional data set. What is a two-dimensional data set means? A data set that has x-axis and that has y-axis. Okay, and the perfect example for this is a table. If we have a table, let's suppose this is my table. Okay, in this table I am having lot of columns and I am having lot of rows. Yes or no? What is a table? Table consists of columns and rows. Okay, with the help of columns and rows you build a table. Okay, let's suppose over here I'm having one column as height. Okay, over here I'm having height. Over here I'm having my weight. Okay, now I want to find out the BMI. Okay, I want to find out the body mass index. Okay, now BMI totally depends upon height and weight. BMI totally depends upon height and weight. And if you see, this is kind of a table. It is looking like a table. Over here I will be having all my height data. Over here I will be having my all the weight data, and corresponding to that, based on height and weight, I will be having my BMI value over here. Okay, let's, for example, for the first student my height is 12. Second student, let's say the height is 17. Okay, and for the third student the height is 10. Okay, similarly, let's say we have weight. Weight is 60. Weight is 70. And then we have weight as 80. Okay, now similarly with the BMI as well, let's go with 30. We have 33, and we have, let's suppose, 35. Okay, now isn't it looking like a table? Isn't it looking like a table where this height, weight, and BMI are the columns, and all this data are the row? This is the first row, this is the second row, and this is the third row, right? This is my first column, this is my second column, this is my third column. Isn't this looking like a table? Yes or no? Yes or no? Right? Okay, perfect. Now over here, if you look, like, it is a two-dimensional data set. Over here this is my x, this is my x axis, and over here this is my y axis. Over here this is my y axis. Okay, so similarly in pandas we have some data structures. Pandas data structure. Okay, so far we have studied about the Python's data structure, right? So in pandas as well we have three kind of data structure, that is series, we have data frame, we have panel. Okay, series data structure is for the one-dimensional data. Okay, data frame is for two-dimensional data, and panel is for more than two-dimensional data. Okay, so let me write over here 1D data. You can say 1D data set, whatsoever you want to call this of. Then we have two-dimensional data. Over here it will be, you can call this as three-dimensional plus. Okay, so whenever you get a data set, whenever you get a data in machine learning and in data science or any domain of data science, you will be working with a data set. Okay, and generally data set is of two dimension. Okay, even in the DB as well, you store everything in a form of rows and columns, right? Over there as well, the table will be in a form of two-dimensional data set. Okay, so most of the time, approximately 97 to 99%, you will be dealing with a 2D data set. Approximately 97 to 99% of the time, you will be dealing with a 2D data set. That means you will be having the x-axis and you will be having the y-axis. Okay, then the second position will going to go to this to 1D data. Then if at some cases you will be using 1D data if you want to make a data frame from series. And this is very rarely you will going to find out someone using panel, because panel is being used for 3D data, 4D data, 5D data set, or so on and so forth. That means in the upcoming time, if we are going to experience such kind of data that in a form of 3D data that has a 3 dimension, right, that has 3 axes or 4 axes or n number of axes, we going to use this panel. Okay, so generally we use this data frame. Till here it's clear? Till here it's clear, yes or no? Okay, perfect. So over here we generally focus on this data frame. Data frame is a collection of series. Okay, and now we're going to experience how we can use this data frame with a real life example. But before going on to that, we're going to discuss about some concept about machine learning. We're going to discuss about some concept of machine learning. Okay, now when we talk about this term, that machine learning in a very general point of view, if I have to convert this in a passive form, I'm going to say machine is learning. Machine is learning, right? What we understand about the term machine learning, machine is learning. But what exactly is the requirement of this machine learning? What exactly is the requirement of machine learning? Okay, so if you want to understand about this, you need to first understand where exactly this machine learning stands out. So we have a chart like this. Let me put a layer by layer, and this is a layer. Okay, so over here we have AI, that is our artificial intelligence. Okay, then we have machine learning, ML, and then finally we have DL. So if you look very closely, you will going to find out that deep learning and machine learning are the subset of AI. Deep learning and machine learning are the subset of AI, whereas AI is the superset of machine learning and deep learning. Machine learning is a subset of AI and DL is a subset of machine learning, right? And over here, what exactly is data science? This is data science. This is what is known as a data science. Okay, this is data science. Data science is more focused. It's not only about training a model. No, data science is all about from scratch till production. From scratch till production, like we have full stack, right? Like we have full stack. So data science includes the full stack as well. Data science includes the full stack as well. Okay, now the need of machine learning is that we have found out that as we are going towards, we have getting a lot of data. Okay, there are several companies such as we have Facebook, we have Twitter, we have Google. Okay, so it has been noticed that they are generating a lot of data, and based on that data they are perfecting their products with the help of their with the help of the data. They are perfecting their products. Okay, so let me give you an example. Let's suppose uh, this is our India. Let's suppose this is our India. Okay. Okay. Let's suppose this is our India. Okay. Now, what happened is that Facebook had different products. Okay. They have Meta, they have Instagram, and they have WhatsApp. These are the three products of Facebook. Yes or no? Yes or no? Yes or no? Okay. Now what happened is, now Facebook has decided to launch their new product. Facebook had decided to launch their new product. Okay, let's suppose their product name is XYZ. Okay, so now Facebook has to decide that okay, we are launching this product, but I want to know which part of India, suppose this is the product specifically designed for India. Okay, for an example, now they will not going to release this product generally, definitely not, right? So before releasing any product, the company first study their perspective, they study about the customer, they study about the behavior of the customer, and where this product can be successful. Okay, now what happened, based on the data of Meta, Instagram, and WhatsApp, okay, they can easily find out a lot of insights. They can easily find out a lot of insight. Okay, let's suppose if Facebook wants to find out, uh, what is the region, what is the region what is the region that are using Facebook app more frequently. What not what is what are the regions what are the regions that are using Facebook app more frequently? Okay, so what happened is, based on the data generated by Meta, Instagram and WhatsApp, they will going to list out the top 10 states or top 5 states in India that are more frequent or more active on this app. Okay, let's suppose they have generated a data and they found out that Mumbai people, then we have Delhi people, then we have Bangalore people, then we have, let's say, Kolkata, and finally we have Chennai. Okay, so based on their statistics, they have developed that these are the 5 states where people are more frequently using Facebook apps. So if we want to launch this app, in the initial stage, or if we want to ask people about their feedback, or if we want to survey about this product, we should go and ask to people who are living in these states. We should go and ask people who are living in the state, will this product will going to help them out, so that initially they will going to launch this product over here in this state, and based on their responses they will going to expand. Okay, so there's a lot of things that the company take in holds when they launches something. Okay, it is not like that the company has dreamt about some product and next day they execute the product and then they deliver the product. No, it never happens. They first study about the availability, they first study about the needs, then they study about the capital gain, that will our product will going to help us a lot or not. Okay, similarly, if I have to give an example, you must have anyone must have heard about Google Plus. Google Plus, anyone? It was like an app that Google has developed. It was Google Plus only, right? So Google has developed this app. Let me show you this app, Google Plus. Okay, this was the app that Google has started, because what happened is, during that time when Facebook has got a lot of attention, right? People were using Facebook, that, oh, that's something unique that we can easily connect from, to another people from sitting at one place, and so on and so forth. So what happened is, Google has launched the exactly same replica of Facebook. They have named it as Google Plus. So what they have decided, oh, every people are using Google, so let's introduce Google Plus, and people will going to move from Facebook to Google Plus. Okay, now what happened is, when Google Plus has launched, because Google Plus gave all the facilities that the Facebook gives, but their input was, their UI was not that much good. They had failed to make an impact, and that's why after some time Google has discontinued this product, Google Plus, because at that time Facebook has already grabbed a lot of market share. Okay, Facebook has already captured a lot of people's attention, and they have a lot of customer bases. So now people who wants to go on to the Google Plus, they feel like very awkward, because the UI was not that much interactive as the Facebook, and over here they were not having much user. That's why after some time Google Plus was a huge failure from Google. Okay, you can read about the research paper as well. Okay, so first of all, you have to study about the market perspective, and how you're going to study about market, all the data that the company generates. Nowadays, everyone knows that all the companies steals the data. Okay, all the companies steals the data. I hope you must are aware about this thing. Yes or no? Yes or no? All the companies steals the data. You must have heard about this term, and in the frequent years you have must have seen that Facebook is stealing our data, Google is stealing our data, right? Even though the application that you install are stealing your data. Okay, the application that you install are stealing your data. Okay, let me show you. Let's go on to Play Store. Let's go on to this Play Store. Okay, let me show you an example. So I believe that many of you are having the WhatsApp application in your phone. Yes or no? Give me a confirmation. Are you guys having this on your phone? Yes or no? Yes or no? Come on. Right? Perfect. Now if you see, this is your WhatsApp Messenger. what happens is when we want to install any application, we simply search on Google Play and then we install about that. Hardly we read about what data are we providing to this application. Hardly we read about what data and what permission we are providing to this application. If you scroll down a bit, you're going to see there's a permission written over here. There's a permission. That means in order to use this application, you have to give the permission to this application. And what are the permissions? Let's see this. You are giving the permission about your photos, medias, and file. That means if Facebook wants, they can easily go on to your photos or your gallery. They can see your photos, they can see your medias, they can see your files. Okay. If they want, they can search for your contacts. If they want, they can search for your Wi-Fi connection, how much storage you are having, how much storage you have filled up, how much storage has been occupied the application. All the information is been given to the company. And over here, phone, that means you are giving the authority to a company or to this application that you can easily make a call. That means if someone wants to hack your phone itself, right? If I want to hack your phone, what I can do is I can implement an app, okay, and I can upload this on some site and all that, and I tell you that please install this, okay. Without reading on to the permission, if you install that application, what will going to happen? As soon as you will going to provide the permission to this application, the hacker or me who have designed this app will going to get an access to your entire phone. So with the help of this, you will not going to even know I can make your call, I can steal your data, and I can do a lot of things. Most probably over here, if you see location as well, you are giving the authority to find out the location. You are giving the authority to record the audio. That means even though if you don't know, the company can switch on your microphone and they can hear all your conversation that is happening, and you will not even going to know about that. Over here, device and app history, your device ID, and most probably camera. Most probably the camera, you will not going to know about that someone is using operating a camera and they will going to snap an image from your front camera itself, because you are giving them the authority. And these are a lot of things that you are accepting. Okay, so by this, all this company generates data. All this company generates data, and data today is very, very important. Okay, they sell the data. You must have seen, or you must have assumed that when you have purchased your first SIM card, okay, let's suppose you went to a shop, you say that, hey Airtel, I want to purchase a SIM card, and the number is somewhat like 1 2 3 4 5 6 and 9 10. Okay, this is a fresh number, this is an absolutely fresh number you have purchased, okay, and you have not given this number to anyone. But after, just assume that after 10 or 15 days, you will going to find out that you will be receiving a random calls, random SMS from random companies that please take our products, please see our products, and so on and so forth. And you will be assuming that this is a fresh number and I haven't given to anyone, but still people who I don't know are giving me message. Does this happen to you? Yes or no? Does this happen to you? Yes or no? You must have seen like this. Yes or no? Right? Yes or no? Okay. So what happened is, as soon as you purchase this this phone number, what is happening? Airtel will going to have your information, the name of the customer, the email of the customer, the phone number of the customer. Now what happened? These companies sells your data. These companies sells your data to the company who are, like, you can say they are the e-commerce company who want to sell their products. They are some or the other kind of companies, right? And they buy your data with a certain amount, and then they will going to call you. That known as a cold messaging or cold calling. Then they will going to call you, so that they know that if we are purchasing about 100 contacts, if we are purchasing 100 contacts, there's a 100% chance that at least from this 100 contact, at least we are going to make 5 customers. Yes or no? Yes or no? Very general thought on this. Yes or no? Right? Okay. So in this way, today the data is being circulated. Data is very, very important. In today's era, data is so important because with the help of data, you can grab a lot of insight. Even though nowadays people are saying like this as well, that even though you don't know about yourself, but Google knows much more than about you, because they know when you eat, when you sleep, and whatsoever you do. Okay, so nowadays data is very, very crucial, and based on this data we predict, we make our machine learning model, we give this data to our machine learning. Okay, we are going to give this data to our machine will going to understand the pattern, and based on that machine will going to predict, based on that machine will going to predict. Okay, so what happened is, suppose I am having a data with me. The data says that on Monday it was a rainy season, or it happened to be rain. Okay, on Tuesday again it happened to be rain. Okay, on Wednesday again it happened to be rain. On Thursday it was sunny. Okay, on Friday it was rain again. Now based on this data you need to find, or you need to predict out what will going to be the weather for Sunday. Now see now see this is totally, you have to understand the difference between the data analysis versus the machine learning. You have to understand about the difference between the data analysis and machine learning. Data analysis means to give you the insight of your current data. That means whatso data I am having, I will give some insight that okay, on Monday it has rain, or 4 days it has happened to be rain. Okay, with data analysis you cannot predict the future. But with machine learning you can predict the future. This is when I'm telling you that based on this data you need to predict out what will going to be the weather of Sunday. That means over here we are using machine learning. When I say based on this data, give me some insights. Some of the insights are there are 4 days when it happens to be rain, and one day we are having sunny. That means I am grabbing information from the data itself. That is known as a data analysis. When I say based on on this data you need to predict something, that is known as machine learning. That's a huge difference between a data analysis and a machine learning. Is this clear? Yes or no? Okay, is this clear? Perfect. So you need to care about the data, because data, it is very easy to store the data. It is very easy to steal the data. Okay, all the companies steals the data, but only the thing is they are not going to disclose it. They are not going to disclose it. If you have seen an interview, not an interview, but a clip where Sundar Pichai was in front of a jury, and jury has asked them that if I move from one place to another, do Google know about that? Anyone have heard about? Anyone have seen about that clip? Anyone? Anyone? It's a very famous clip where Sundar Pichai was sitting in front of jury, and jury is asking them that I am having this phone, and this phone has installed a Google Map, right? If I move from one place to another place, do Google Map knows, or do Google know about that, right? Now see, what is the reply of Sundar Pichai? He told him that if you are giving the permission, if you are giving the application the permission, then definitely, if you are giving them the permission, then definitely. So now see, the very basic term over here is that yes, we are stealing the data, but we are going to improvise is in this way, that we are not stealing the data, it's the customer who is giving us the data. We are not stealing the data, it's the customer who is giving us the data. Okay, so now you need to understand about that whatso app you use. First, kindly read about the permission. Because the reason being is that anyone can make an application, Okay, that application can be a hacking application, and in order to use that application you have to provide the permission, and as soon as you provide the permission to it, okay, so other person who might have installed or put up something fishy in that application, they can easily hack your phone, and even though you will not going to get a hint that your phone has been hacked. Okay, so kindly read about this, because currently people are moving towards data, people are selling data, people are purchasing data. Let's move on to the next part to understand about machine learning more in depth. Okay, when we talk about machine learning, okay, machine learning has been divided into three parts. That means we have three types of machine learning. One being the supervised learning, one being the supervised learning. Okay, one being the supervised learning, another being the unsupervised learning, and the last being the reinforcement learning. Reinforcement learning. Okay, unsupervised learning is that you will going to teach machine, a human will going to teach a machine. That means, let's suppose take an example. Now over here, if I say you are having an exam in the upcoming time, let's suppose you are having a mathematics exam. Okay, now you have to train yourself in mathematics. Okay, you're having a mathematics exam, so definitely you will going to train yourself in mathematics, you're going to learn about mathematics. So how you're going to train yourself? Let's suppose over here you are having a question. Okay, you're going to see that question and you are going to solve that question and you will be getting some answer. Now to correct yourself, what you are going to do, you will going to tally the answer, tally your answer with the provided answer. If your answer comes out to be, let's suppose, 7, okay, now you want to check whether this 7 is the correct answer for this question or not. So what you do, you will going to check for the answer key, you will going to check for the answer key, right? If answer is 7, that means you have done well, you have done well, you have scored 1 point or 5 marks or so on and so forth, right? Now if you say answer is 9, answer is 9 and your answer comes out to be 7, that means now what you will going to do, the next time you will going to solve this problem, you will going to take the concept in account, you will going to provide the right formula so that you will be achieving the right answer. Yes or no? Yes or no? Yes or no? Right? Okay, okay, so over here you are having an answer key. In supervised learning, you provide an answer key to the machine that, hey, this is your question, based on the question you provide some answer, machine will going to provide some answer. Now machine will going to tally the answer, this is a predicted answer, this is the predicted answer, and this is the actual answer, this is the actual answer, this is the predicted answer. Predicted answer means that the answer that machine has predicted. Okay, now what will going to happen is machine will going to tally the answer that, hey, this was my answer and machine and the real answer is this, that means machine has made a mistake. So next time machine will going to give an answer that will more close to the actual answer, that will more close to an actual answer, somewhat around 8.9. 8.9 is close to the actual answer. Yes or no? It is too much close to the answer. Like this, machine will going to understand with the help of the answer key provided. In supervised learning, you will not going to provide any answer key. You just provide a question and that's it. Machine will going to provide answer, but we don't have any answer key over here to tally. We don't have any answer key to tally. We call this as a labeled output. We call this as a label output. In supervised learning, you will be having a target variable. You will be having a target variable. Okay, this target variable is known as a label data. Label data. Okay, in unsupervised learning, you will not going to have any target variable. In unsupervised learning, you will not going to have any target variable. Okay, that's the difference between supervised and the unsupervised. Okay, so in supervised, data are labeled, In unsupervised, data are not labeled. In supervised, you are having a target variable. In unsupervised, you are not having any target variable. Okay. Then we have a reinforcement learning. Reinforcement learning is the same way like human behaves. Is the same way like human behave. That means let's suppose we are having a toddler or a baby. Okay, you want to teach this baby about alphabets, A B C D and all that, right? You told them that, hey, this is A. This is how you draw an A. Okay, now there are more than 100% chance that on the first go, this toddler, this baby will not going to make a perfect A. Yes or no? Yes or no? Right? Yes or no? Right? So let's suppose the baby has made an A like this. Let's suppose this is what a baby had made. Okay. You will tell baby that, okay, see, this is A. Okay. But now you have to make like this A. So the toddler we're going to learn from its mistake. So the next time he or she will going to make A, it will be more accurate than their previous result. It will be more accurate than their previous result. It may be like this, and slowly they will going to reach to the final point where they can easily make an A. So the similar concept has been used in the reinforcement learning. Similar concept has been used in this reinforcement learning, where machine will going to learn from its mistake. Where machine will going to learn from its mistake. It's just like a game. Okay, reinforcement learning is just like a game where you do something good, you get a point. Where you do something bad, your lives get deducted, or your points get deducted, and so on and so forth. Okay, so reinforcement learning is where machine will going to learn from its past experience, just like human do. Is this clear? Is this clear? Yes or no? Target means dependent variable. Exactly. Target means dependent variable, and features means independent variable. Okay. Now furthermore, supervised learning has been classified into into two types. First is regression, and another being is classification. Another is classification. Okay. So since I have mentioned that in supervised learning you will be getting a target variable. Okay, target variable is always a dependent variable. Okay, and all other features are an independent variable. That means you need, based on the independent variable, you need to find out the target variable. Based on the independent variable, you need to find out the target variable. You will going to go with regression when your target variable you will going to go with regression when your target variable is of continuous value. When the value in this target variable or in this target column is a continuous value. Continuous value means like this: 0.4, 2.4 or 2.0, so on and so forth, or the continuous value. You will going to go with classification when your target value is of any categorical value. If you're having any categorical value as in, let's suppose we have a categorical value as let's suppose survived and not survived. This is a categorical value, yes or no? We have two categories over here. One is a survived and another is not survived. Based on all the features and all the data points, we have to predict whether the person has survived or the person has not survived, whether the person has an heart attack or not an heart attack, whether the person is having a cancer or not a cancer, right? These kind of statement falls under the classification problem statement. Okay, so in supervised learning we have regression, we have classification. In unsupervised learning as well, we have two parts. We have clustering and we have association. Now clustering and association is very important, right? Because the reason being is, based on these two, clustering and association, nowadays the e-commerce websites and e-commerce platform are earning more than 30% of their revenue. Okay, so over here we understand about the market basket analysis concept and the recommendation concept. Till here, is it clear? Till here, is it clear? Yes or no? Till here, is it clear? Yes or no? Okay, perfect. So let me show you how exactly e-commerce website uses machine learning. Okay, so many of you are familiar with this website known as Amazon.in. Okay, let's go. Let's say I search for laptop. Okay, I search for laptop. These are some of the laptop. These are some of the laptop. Let's go with this laptop. Okay, this is a laptop. If I'm going to scroll down, over here it is not showing. Let me try with other laptop. Uh, if we scroll down, over here as well, it is not showing. Let's go with this laptop. Okay, over here, if you see, this is a laptop. My only focus, the customer focus, was to purchase this laptop. But now if I scroll down, can you see this section, buy it with? This is known as the market basket analysis. This is known as the market basket analysis. Okay, that comes from association. It tells you that if a customer is purchasing this laptop, there are high chances that the customer will also going to purchase these bags. There's a high chances that a customer will going to purchase this bag. So that customer will going to come up over here and will say, okay, I want to buy, my first motive is to buy this laptop. But yes, if I want to go from one point to another, I need a bag as well, right? So I want this bag as well. So it's perfect. So instead of purchasing only one item, now customer will going to purchase two or more item. This is known as the market basket analysis. Okay, and second, we are having recommendation system. This is the recommendation system that you are having. That means based on that product, these are some of the recommendation. Based on that product, these are some of the recommendation. That the product was of Lenovo something something. Over here they will going to show us some of the products that fits on to the requirement, so that if you don't want to go with that product, you can go with another product. So based on these two features, on the recommendation system and the market basket analysis, more than 30% of the revenue is being generated for all the e-commerce website. And nowadays this is very common in all the e-commerce platforms. So now what is happening, that all the companies are trying to build machine learning models for the market basket analysis and the recommendation system, so that it automatically enhance their revenue system. Is this clear? Okay, perfect. So similarly, we have clustering and we have the association in the unsupervised learning, where we study about the customer behavior. Okay, so this is all about the machine learning. Okay, if you want to go deeper in machine learning, so let me write some of the models or algorithms that you can refer to. If you want to go with regression, you can refer to linear regression. These are the algorithms that you can easily refer. Okay, linear regression. You can go with lasso regression. You can go with ridge regression. You can go with decision tree regressor. You can go with random forest regressor. You can go with SVR, that comes under SVM, support vector machine, that is support vector regressor. Okay, if you want to perform classification, you can refer to logistic regression, KNN, that is known as the k nearest neighbor. Okay, and then we have decision tree, classifier, we have random forest classifier, we have support vector machine that has support vector classifier, support vector classifier. Okay, if you want to perform the clustering, if you want to go with clustering, then you can go with k-mean clustering. Okay, or you can go with db scan. Okay, if you want to go with association, then you can go with a priori, and you can go with eclipse. Okay, these are some of the algorithms that you can easily refer if you want to work either in the regression, classification, clustering, and association. Is this clear? Is this clear? How to add machine learning to a website? Okay, so suppose you are dealing with machine learning, you have done with your machine learning, you need to pickle your model, you have to dump your model, take that model file into the next part, and then connect your model with the software. It is very easy. It is very easy. In the upcoming time, from 4th of January, I'll be taking a bootcamp in which I will be explaining you how you can create a model, how you can use that model to create a website, and you can host it as well. Okay, so do attend that if you want to. Okay, now let's understand how we can perform machine learning based on pandas. Okay, based on pandas. Okay, we're going to study about linear regression. Linear regression means that you will going to find out the relationship between the target variable and the feature. Okay, let's suppose my target variable is let's say BMI. Okay, and my independent variable over here is age. So now I have to find out the relationship. What exactly is the relationship between this age and BMI? Okay, so they will going to make a linear relationship. This is known as a linear line. Okay, this is known as a linear line. It states that as the age is increasing, the BMI is also increasing. So the covariance over here is a positive covariance, and the correlation will be based on to the points that we're going to mark and make this kind of relationship. Okay, so we're going to find this out on the practical session. So shall we start with the practical session? Yes or no? Shall we start with the practical session? Shall we start with the practical session? Give me a confirmation. Perfect. Awesome. Okay, so before starting, we are going to import some of the libraries that we are going to use for our linear regression. Okay, we are going to import NumPy and as NP. NP is an ls. Okay, I'm going to import pandas as PD. I'm going to import matplotlib. This matplotlib is a library for the data visualization. Okay, and I'm going to use Seaborn as well. Seaborn as SNS. Okay, so this Seaborn is also for the data visualization. Import RE. RE is for the data cleaning. RE is for data cleaning. Now I'm going to import the model, linear model. I'm going to import the linear regression. Linear regression. We are going to import the train test split, model selection, train test split, and we are going to import a matrix to check the accuracy. It's not from, it's from sklearn.matrix import r2 underscore score. Okay, let's run this. Perfect. Okay, we have installed this part. So this is my model linear regression. That means we are going to do with the regression problem statement. Okay, Now this train test split means we are going to split our data set into two halves. One for the training purpose, another for the testing purpose. Okay, one for the training purpose, another for the testing purpose. That means if we are having this data set, okay, we are going to make a half of this data set. So that let's suppose this is the half. So now I am having two half. This half will going to known as a training data set. Training data set, and this half will going to known as the testing data set. That means this training data set will be shown to the machine so the machine can train itself. Okay, now we are going to test machine with this testing data set which the machine has never have seen. Okay, never have seen before. So based on the testing data set, we're going to find out the accuracy. Okay, now over here as well we have two parts. One is the X and one is the Y, where X is the features and Y is the target variable. So let me write over here. X means the features and Y means the target variable. Okay, that means this is our answer key. Target variable means this is our answer key. So machine will going to learn from X feature. It will going to say, okay, these are the X feature. Machine will going to provide some output and then they will going to tally their output with their Y. Okay, with the help of this machine will going to learn itself. Now in the testing phase, we will not going to provide the feature and the target variable both. We are only going to provide the feature. Machine will going to give us some predicted result. Then we are going to match this predicted result with this actual result, and based on these two we are going to find out the accuracy. That means how efficient our model is. Is it clear? Yes or no? Okay, perfect. So let's see this. So today we are going to use this data set. Okay, now if you want to, now I'm having a data set. Now I want to put this data set over here in my Colab or in my VS Code or PyCharm, so on and so forth. How can I bring that up? I can use Pandas function as a read CSV to bring that data set so that I can work on this. Okay, let's say this is my variable. I'm going to use this function known as read CSV. That means if we look very carefully to this file, the extension is CSV. The extension is .csv. That means this data is a CSV file. This data is in a CSV file, right? So I'm going to say you need to read a CSV file, and this is my CSV. Okay, let's run this. And now if you want to see your data, just print your df. You will going to look that the data from here has been brought up over here. Okay, so we have two columns. We have temperature and we have revenue. Okay, so this is a data set taken from an ice cream store. Okay, this data set has been taken from an ice cream store where they have seen that whenever the temperature is this is the revenue that they have generated. Okay, whenever there was a temperature is 24 degrees Celsius, the revenue they have generated is this. That means obviously for the ice cream, as the temperature increases, the revenue will also going to increase. As the temperature will going to increase, people will going to purchase more ice cream, so that revenue will also going to increase. Yes or no? Yes or no? Yes or no? Give me a confirmation. Okay, perfect. So I'm going to find out that, okay, this is a temperature, this is a revenue. I am going to train my machine based on this data, so that I will be giving some temperature and machine will going to tell me that if this will be the temperature, what will going to be the revenue. Okay, very simple. So over here my temperature is my feature and my revenue is my target variable, and I'm having two random variables, that is temperature and we have revenue as well. Okay, now we have a function. Suppose if you want to see the top 5 data, points. Okay, so in machine learning, we don't call this as a row. We don't call this as a row. We call this as a data point. Okay, so the total number of data points is 500. Okay, so I want to see the top 10 data points. So I'm going to use a head function. I'm going to say 10. That means top 10 data points. It will going to print out the top 10 data points. Okay, if you want to print top 2 data points, top 3 data points, you can put up over here the number, and the top X number of data points will be presented. Similarly, if you want to look forward to the bottom 5 or bottom 10 or bottom 15 of data set, you can go and find that out as well. We have a tail function. Okay, so if you say tail 10, you are going to find out the last 10 data points are being presented. Last 10 data points are being presented. Okay, is this clear? Is this clear? Is this clear? Yes or no? Okay, perfect. Let's move on to the next part. Now, if you want to check information, do we have any null values or do we have to clean any values and all that? We have a function known as an info function. That means information. So if you see df.info, if you see this, you will going to find out this info function will going to give us a lot of information. It will going to tell you how many data points are there. There are 500 entries. How many not null values are there? That means if there will be a null values, you have to treat that null values. You have to treat that null values and you have to make a data set a null free data set. Because if your data set is not clean, it will going to affect on the accuracy, and it will going to provide you the data type. That means the data that has been added in this column, what are their data type? If you see, the data type of this value is a float, right? So it will going to tell you the data that has been provided in this column, the data type that they're following is a float, and similarly over here it is a float. If you want to find out some statistical information, you can use df.describe. You can use df.describe function. This will going to give you some statistical function. That means the total count, that means total number of values in temperature, total number of values in revenue, the mean of temperature and mean of revenue, standard deviation minimum. That means the minimum temperature is 0. The minimum temperature is 0, and the minimum, the least revenue that has been generated is 10. Okay, this is a $10. Okay, 25% of the data, these are for the quartiles. This is your first quartile, second quartile, and third quartile. Second quartile is known as the median as well. Okay, this is for 25%. This means that 25% of data lies over here, 50% of data lies over here, and 75% of data lies over here. And maximum the temperature has went to 45 degrees Celsius, and the total revenue has been generated as $1,000. Is this clear? This describe function will going to give you the statistical information. Is this clear? Is this clear? Quartiles are the concept of statistics. Okay, we have a lot of quartiles. We have already studied this quartile during our school as well. Okay, perfect. So now this data is completed. This data is absolutely completed. Since we have a lot of things to explain you, right? How we have to manage the data, how we have to clean the data. But since the time is very less for this boot camp, so we cannot offer everything in this part, right? So that's why we have to go a lot of fast to this pace. Okay, now without any further ado, let's train our model and let's see the accuracy of a model. Okay, so now first we have to define an object for this model. What model we are using? We are using linear regression. Okay, so we're going to say linear regression. This will going to create a model. Okay, now we have to split our data into two parts, that is the training set and another is the testing set. Okay, but before that we have to provide two variables, that is the x variable and the y variables, where all the feature will be stored in the x and all the all the target will be stored in the y, right? So over here the feature that we are having is a temperature. Temperature is my feature. Okay, and one more thing that I want to show you, that if you see the dimension, it is a two-dimensional data set. It's a two-dimensional data set. See, it's a two-dimensional data set. Okay, so df.temperature, df, and we have revenue. we have revenue. That means in x-axis I'm having my feature, in y-axis in y variable I'm storing my target variable. Okay, so let's run this. Okay, till here it's clear. Till here it's clear. Yes or no? Till here it's clear. Okay, perfect. Now we are going to split our data set. So we are going to say x train, x test, y underscore train, and y underscore test. Okay, now we are going to use a train test split. We are going to use train underscore test underscore split function. Over here we are going to provide the x and y to split this data set, so that it will be going to have x train, x test, y train, y test. If you see this example, this portion is known as the x train because this is a training data set. So this is your x train. Okay, and this is your testing data set, and this comes from x, so it will be x test. Okay, this is your training data set and it falls under the y, so it will be y underscore train. Okay, and similarly this will be y underscore test. This will be y underscore test. So we have x train, x test, y train, and y test. So that's the same thing over here I have done. Okay, x train, x test, y train, y test. Okay, now since this train test split says that we are going to take the feature in it should be in 2 dimensional, whereas you can have your target variable in 1 dimension. Okay, if I'm going to run this, it will going to give me an error. Now see this, if I'm going to run this, why didn't give us error? Okay, this will going to help in model. Okay, now this x train, let's print this x train. Perfect. So this is our x train, and if you see the length of this x train, if you see the length of this x train, it is 375. Total number of data set that we are having is 500. Total number of data points that we are having is 500, right? Now it has been split to x train, x test, y train, and y test. X train is having 370 data points. Similarly, y train will going to have the 370 data points. X test will going to have the remaining 125 data points, whereas the y test will going to have the remaining 125 data points. Okay, let's print this up. X underscore test 125. Okay, now y underscore train, it will going to have 375 data points, and length of y underscore test, it will going to have 125 data points. 125 data points, right? Now we have to train our model. Okay, so we are going to say model dot fit x underscore train and y underscore train, because we are only going to provide the training data set to the model. We're only going to provide the training data set to this model. Now this x train over here is a 1-dimensional data set, and this y train is 1-dimensional as well. So as soon as I'm going to run this up, now see, I'm getting an error. And what an error it is? An error, it says that you need to use the reshape because I cannot take x train as a single dimensional data set. I cannot take x train as a single dimensional data set. So over here, if we see endim, you can see the data set over here is 1-dimensional data set. Data set over here is 1-dimensional data set. Okay, the target variable can be of 1-dimensional data set, but the feature cannot be of 1-dimensional data set. That's why we are going to use the reshape function -1 and 1, so that it will automatically going to what's the issue? CS has no object as reshape. So what we can do is, instead of using a reshape, we can use the df dot xtrain. Till here it's clear, yes or no? Till here it's clear, yes or no? Till here it's clear, yes or no? Give me a confirmation. Okay, perfect. Only 5 minutes more, 5 minutes more, and then we're going to wrap this up. Okay, only 5 minutes more, then we are going to wrap this up. Perfect. So let's move on to the next part. Okay, so over here it's saying that you need to split this data set. You need to split this data set. We have splitted our data set. Now, when you are dealing with this kind of situation, you need to make sure that your data set, this portion, that means your training part, should be of two-dimensional data set. It should be a two-dimensional data set. And over here, it is our one-dimensional data set. It can be one-dimensional, but this X-train needs to be of two-dimensional data set. Okay. Now, if we check over here, this X-train comes out to be NDIM. Sorry, it comes out to be one-dimensional data set with respect to this NDIM attribute. This NDIM is from NumPy. So we need to change this X train from one-dimensional data set to two-dimensional data set. Okay, so if we see over here, what we can say, X underscore train, let's print this X underscore train. This is our X underscore train. Finally, if I say X underscore train is equals to list of X underscore train, let's run this. And now if we say X underscore train, you can see everything is in a form of list. Now, if I check this NDIM, it will going to comes out to be one dimension. Okay, let me do this into np.array. Okay, now it will going to show you the n dimension as one dimension, right? I need to convert this into two dimensions. What I'm going to provide? I'm going to provide a two-dimensional part over here like this. So now if you're going to check this, you're going to find the dimension has been changed to 2. This is what we have already discussed yesterday, right? Now if I'm going to run this, let's run this. What is this? Found input variables with inconsistent number of samples, 1, and we are having X underscore train. Let me do reshape -1 and 1. Perfect. So model is being trained. Now we have to predict our values. So we are going to say model.predict. We are going to give X underscore test. Okay. Similarly, the thing that we have done with X10, we have to do with X test as well. Okay. So let's do this. X underscore test is equals to np.array of X underscore test. Okay. And reshape -1 and 1. Now these are been predicted values. So let me store this predicted value into y is equals to, y underscore predict. Now all the predicted value has been stored to y predict. Now I want to check what is the accuracy of my model. So I'm going to use r square. And over here I'm going to provide y underscore test and y underscore predicted value. And the accuracy of my model is approximately 98%. Approximately 98%. So my model is a good model because over here I'm getting an accuracy of 98%. So if I give any temperature, so there are 98% chances that my model is going to predict the more closest revenue. Is it clear? Is it clear? Yes or no? Is it clear? Yes or no? Okay. Perfect. Let me provide this data set so that you can practice this on your own. See, data cleaning and data preparation is very, very important, but we don't have that much time to discuss on that, right? We don't have that much time to discuss on that. So hardly we have, we have to go fast and we have to cover the entire data, machine learning and all that. Okay. Now, tomorrow, based on this example, how you can use a machine, tomorrow I will be explaining you what will be the data set. Okay. What will be what you need to do, okay, with that data set, and what are the steps that you need to follow. Okay. Based on that, you need to perform the machine learning using any model. If you want to go with linear regression, you want to go with any kind of regression technique, you can go on, and you have to submit that project. And based on that project, you can easily get the certification. So certification, if you want to have a certification, so projects is very, very important. Okay, you can also do yes, you can do machine learning in Java as well, but Java doesn't have that much uh, libraries and packages and so on and so forth, so it will be very difficult for you to achieve machine learning in Java, but you can do machine learning with Java as well. These machine learning this collab file will be given to you tomorrow. Okay, all the thing will be has been done in the same collab file, and this collab file will be shared with you tomorrow. Okay, perfect. You will be getting a link to submit your project in your respective WhatsApp group or your Telegram group. Okay, perfect. So that's the entire wrap for today. So today we have covered about machine learning, what is machine learning, and we have also seen one model, that is a linear regression model, and we have achieved the accuracy of approximately 98%. That means our model is doing very well. Okay, you will be getting a week time to submit your project. Okay, you will going to get a week time to submit your project. If you don't have any system or laptop or your computer, you can use Google Colab itself from your mobile. Okay, from your mobile only you can use this Google Colab, and you can easily do your project and submit your project with the help of their link. Okay, tomorrow I will be explaining you about what you need to do in the project. Okay, perfect. What is reshape minus 1 and 1? It means that you will going to reshape the entire data. You will going to reshape. That means currently we are having a shape as 1. I want to reshape it into 2, 3, 4, or 2 cross 3, 4 cross 4. I can easily reshape. The minus 1 means that indicates the length of the list, the length of the numpy array, and then over here the 1 means the column. 1 means the column, how many columns you want to reshape it into. Okay, this is a concept of numpy. Okay, any more question? Any more question? I will be explaining you about the project tomorrow. Okay, so what you need to do and how you have to submit, so on and so forth, I will be teaching you about the project tomorrow. Okay, perfect. About the attendance link, I'm not sure if the team has sent that attendance link on your respective group. If they have not sent, so definitely you will be getting a full attendance. Okay, if you're getting attendance link, you have to submit that up. If you're not getting an attendance link, so everyone is going to get a full attendance. So based on the project, you will be receiving a certification. Okay, is this clear to all of you? Yes or no? Okay, if you want to check for the today's data set, the link has been attached on the chat section at the top itself, so you can refer to that. Okay, so thank you so much for joining in, and let's meet tomorrow, and we're going to discuss about the project. And with this, we are done with our bootcamp for 7 days. Okay, you can use PyCharm. Yes, you can use PyCharm, whatsoever editor or whatsoever software you want to use, or ideally what you want to use, you can go with that. Okay, perfect. We don't have any marks kind of stuff in project. You need to submit the project. Our team will going to check each project. Each submission should be a valid submission, not a copied one, and according to that only you will be getting the Google certification and the Microsoft certification for this bootcamp. Okay, if you want to know the data type of the data, you can use the info function that we have used today. Okay, perfect. Thank you so much, guys. Thank you. Let's meet tomorrow, and we're going to wrap this entire bootcamp tomorrow itself. Okay. Thank you so much for joining in. Let's meet tomorrow. Stay safe. See you all soon. Bye. Thank you.